Welcome back to another video in the quadratic functions series. In this one, we're going to talk about something called vertex form. And if you watched my video on parent functions, or the video where we talked about translating parent functions and moving them around, this is not going to be new. This is just going to go more in depth into the quadratic side of things. And we're going to talk about how you can find the roots of things in vertex form, the Y-intercept, all kinds of stuff. So let me remind you what vertex form looks like. Now, we may not have called it vertex form before. I think we called it point slope form. We did with linear functions, excuse me. But vertex form is going to be a function that looks like this. And if you remember from our parent functions discussion, if you change this sign and don't change this sign, it gives you the new starting point. Now, in that video, we talked about it being like the origin or the starting point where we graphed a thing. But for a quadratic, for a parabola, this is actually just the vertex, isn't it? So this is vertex form because the vertex is visible. You don't have to do any kind of calculations, no manipulations of any kind other than swapping that one sign. Where when we had standard form in our last few videos, you had to use a vertex formula and do a lot of calculations to find that vertex, right? But when something is in vertex form, the vertex is just visible. That's it. Easy. Let's do another one. Let's do y equals x plus 2 squared minus 4. And so remember, to find the vertex, we just swap this sign. So we have negative 2. Oh, excuse me. We do not switch the sign on the outside. And that gives us our vertex. So then we go down here and we graph it. So my vertex is negative 2, negative 4. And then if we wanted to graph this thing, the rest of it, remember we discussed this in our parent functions video. As long as there's not a number out front, we have this pattern that we can do just like this. Okay? And that's what the quadratic looks like. There's our parabola. Now, so far there's nothing new. I just wanted to go over that again. That's the review. But we're now calling it vertex form as opposed to just a general parent function of a quadratic. All right, so now we're going to talk about other things you can do with this. And before we do that, let's talk about the need for it. So let's say you had something like, let me give you another one. X minus 1 squared minus, let's say, 5. Let's graph this one really quick. So if I graph this, my vertex, change colors, my vertex is going to be 1, negative 5, because we switch the sign of the 1 in the parentheses, so we don't switch the other. That's going to put me down here at 1, negative 5. All right, and then my pattern is going to give me this here. Like that. Okay, now that's not hard. But notice when I graph this thing, it doesn't actually cross the x-axis at anywhere that's easy to spot. In other words, these roots aren't whole numbers now. So because this thing is down 5 instead of like down 4, the dots don't actually line up properly. So we need a way of finding what the roots are when we have something in vertex form. Right? Now, one way you could do it is you could turn this into standard form, then use the quadratic formula, and it'll work. But that's a lot more work, and it's kind of a step backwards. So here's what we're going to do. This is a brand new process. I'm going to show you how to do this. All right, let me get rid of this. So our function was, let me actually write this, to find roots for quadratics in vertex form. Here's what we're going to do. whenever you find roots in general, the whole idea is to set it equal to 0, because the point is you're making y equal 0. So remember when we factored, we set it equal to 0. That's how we did it. And then if we couldn't factor, we used that special formula, the quadratic formula. But here, we're still going to set it equal to 0. But this is going to be a very convenient form for us to just solve for x. It's actually quite simple. So we're just going to solve for x. We're just going to get it by itself. So how do I get x by itself? Well, let's move everything that we don't need, everything that's not x, to the right side. So first we're going to add 5 to both sides. That goes away. Doesn't look like a 5. That's a little better. Now I have x minus 1 squared equals 5. Okay. And now I've got to get rid of everything over here on the left, but I can't get to this 1. I've got to get rid of this square first. There's something squared. So think of it, this entire thing squared gives me 5. How do I undo something that's squared? Well, the opposite of squaring something is square rooting it. So if I square root both sides, that should get rid of the square. Now, it doesn't affect anything here. This is important to note. It doesn't affect anything here because what this square root does is it acts on this square right here and it takes it away. So everything inside the parentheses is, you could think of it as being protected. It's not bothered by the square root. You're not going to do any calculations. It's just going to cancel everything out. So now what's left is x minus 1 inside. And now I'm going to take the square root of 5. Well, I don't have to take it yet. So this is going to be plus or minus the square root of 5. Whenever you're asking yourself in an equation situation, what is the square root of something, you need to take the positive and negative version of it when you're trying to solve for x. Now, I need to get x by itself. How do I do that? Well, I'm going to add 1 to both sides. It's just basic algebra. So I cancel that out, and I have x equals. Now, I can't directly add 1 to this yet, so I'm just going to put it out front. 1 plus or minus the square root of 5. And so now I have two answers. I have 1 plus the square root of 5, and I have 1 minus the square root of 5. And those are my two roots. Now, if you wanted to estimate that, we could do that. Let's actually do that really quick. Let me change colors to show that we're doing something a little different. So this is going to be approximately, because once I take the square root, it's not going to be exact. This is 1 plus, well, the square root of 5 is, get my calculator out. The square root of 5 is 2.236, blah, 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 blah. Lots of stuff. So if I add 1 to that, it's going to be 3.2, let's round to 4. And now this is going to be 1 minus that number, which is going to be, let's see. That's going to be 1 minus, oh, hang on a second. Get my calculator working here. Negative 1.24. Okay. All right, so those are my two roots. Okay, very simple. I just set the thing equal to 0, and then I moved the number over, took the square root, and then from there it's just basic algebra. Let's go ahead and plot these and see if this looks right on our picture. So it's 3.24 and negative 1.24. I'm going to go back to my picture. And here, let's zoom in. Here is 3.24 right here. And then here, negative 1.24. And yeah, it looks about right. It's 3 1/4 and negative 1 1/4, approximately. So this is how you would find out exactly where this thing crosses the x-axis, finding the roots or the zeros, the same term, if you're in vertex form. All right, let's try another one. Now let me get rid of this. We're going to go over here, do another example. All right, let's try this one. You try this one real quick. Y equals x plus 3 squared minus Let's go with 16. All right, try that one really quickly, and then come back and see if you got the right answer. All right, here we go. Set it equal to 0. We're going to move the 16 to the other side. So x plus 3 squared equals 16. I'm going to take the square root of both sides. Now what do I have left? Well, that square root cancels the square. The inside is protected. It's just what's left over. Now I can actually take this square root, can't I? I can go ahead and do that. So it's going to be plus or minus 4. And now, again, this is not the answer. You have to get x by itself. That's the idea of solving for x. That's the whole idea. So you have to get x by itself. You move the negative 3 to the other side. Because when you subtract 3 from both sides, it becomes negative on the right. So now I have negative 3 plus or minus 4. And that's going to give me two solutions. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. And those are my two roots. Now, I could go over here and I could plot those. And so that was 1, negative 7. 1, 2, 3, 4, 5, 6, 7. And then if I wanted to plot my vertex, I would go all the way down to, what's that, negative 3, negative 16. But we're not going to do that right now. But this is where those roots would be. Right, let's do one where we have a negative out front. This gets a little more fun. Let's do 2 squared plus, let's do, I don't know, 10. All right, I would suggest, if you want to try this, you can, but I would suggest just watching me do this one, and then I'll let you do another one kind of like this after this. All right, so as always, we're going to set it equal to 0. Move the 10 over there. Oh, that's not right. So it's x minus 2 squared equals negative 10. So I've just moved the 10 to the right side. Now, at this point, you might think, oh, I need to take the square root, but you can't take the square root unless there's just something squared. But that's not what we have here. We have something out front. This is a negative 1 being multiplied. You can't have something there. 1, you can't take the square root of a negative number. But 2, if anything is out front, it's not going to be possible to take the square root and get an answer the way we want. So we're going to have to get rid of that. So how do you do that? Well, if I divide both sides by negative 1, that goes away. So I'm left with x minus 2 squared equals positive 10. All right? So now I'm just back to business as usual. So I'll go over here. I'll take the square root of both sides. Now, I don't know why I'm changing colors every time, but it is kind of fun. All right, so I take the square root. I get x minus 2 equals plus or minus the square root of 10. Now, you could leave it square root of 10 plus or minus. You can go ahead and estimate it at this point. What I like to do is just leave it there for now until I get x by itself and all that manipulation done. So I move the 2 over. It is positive 2 now. Give me that. Now, you can separate it there, or you can do the approximation here. Let's do the approximation at this point. So the square root of 10, let me get a different color. Square root of 10 is 3.16. Oh, I forgot something. Let's write this whole thing out. 2 plus or minus 3.16. All right, so if I have 2 plus 3.16, that's going to give me 5.16. And 2 minus 3.16 is going to give me negative 1.16. And there you are. Now remember, this is kind of interesting. I remember how we talked about in my quadratic function or quadratic formula video how these numbers are going to end up being the same if they're on different sides of the axis, right? The y-axis. And that shows here as well. So if we wanted to graph this, we'd have go over here and get rid of these dots. Delete. So we had negative 1.16, which is about here, I guess, just outside that. And then we had 5.16, if I remember correctly. Oh, yes, 5.16. Sorry for the craziness that was just that. 1, 2, 3, 4, 5. A little bit more. And there we are. And those are my roots. And then if you wanted to graph the vertex, what you could do is go up to, let's see, what was that? It was 2 and 10, right? And it's upside down. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I can't do it on my graph. Well, point is, it's up there somewhere. But that's how you would graph the roots for this one. All right, let's do another one. You try this one. Same concept. Let's try this. All right, give this one a shot. Okay, I'm going to assume that you've tried this. For step 1, set it equal to 0. Now I'm going to move the 16 to the other side. Now some of you, if you haven't done these in a while, you might be tempted to multiply that 2 into this parentheses with a square. That's not something you can do. It's protected by that square up there, for lack of a better term. So what you need to do, if you remember, the goal of this is to get rid of all the numbers, not to multiply it into them. The point is to get rid of it. So how do I get rid of that negative 2? Well, the same way I got rid of that negative 1. You just divide both sides by that. It's gone. So now I have x plus 1 squared equals 8. And now, square root, and I have x plus 1 equals plus or minus the square root of 8. Go ahead and, well, I'll approximate this over here. This is going to be x equals negative 1 plus or minus, oh, I said I was going to approximate it, didn't I? Well, let me do that. Negative 1. All right, so the square root of 8 is 2.83. You'd think as many times as I've done this, I would have remembered some more square roots. Should memorize these at some point. All right, so now I have two roots. I have negative 1 minus that, and negative 1 plus that. So negative 1 plus that is going to be 1.83, and then minus is going to be negative 3.83. All right. Let's try one more, because this is something that you might see. All right, try that one real quick. Okay. So if I set this equal to 0, I move the 25 over. I have x plus 4 squared equals negative 25. At this point on the left, there's nothing else left except for something squared. So at this point, I can take the square root. That's all I have left to do. But now I run into a problem, don't I? Because while I can do that on the left side, you cannot take the square root of a negative number, at least not in the context in which we are working. So remember when we talked about this in the quadratic formula video, we determined that this was the situation where we had no real roots. So even if I move this over here, I still have something that's not going to happen, right? So this means no real roots. Okay, so same as with the quadratic formula, if you have a negative under the square root, you have no real roots. And if you think about what this thing would look like, you should anticipate it from the beginning anyway. Let's actually sketch it real fast. The vertex is negative 4 and positive 25, and it goes upward, right? Which means this thing does, oh, that's terrible. It does this. And no real roots means it's not going to touch the x-axis at any point. And so if you just kind of glanced at this and thought, well, it goes up and it starts above the x-axis, then of course we're not going to have any roots because it never touches the x-axis. That's how that works. Okay, so far we've talked about how to find the vertex, which is really easy. It's just negative 425. You just switch the sign, don't switch the sign, done. We've talked about how to solve for roots. Now let's talk about how to find the y-intercept. Let's actually write that. Finding the y-intercept. From vertex form, obviously. Well, this is a review for a second. You don't have to write this down or anything, but this is a separate review. If I had, like, say, 3x squared plus 5x plus 4, this is standard form, right? And we discussed that this c number here is the y-intercept. So if I asked you, what is the y-intercept of this function down here, you would say, oh, it's 4. Done. Easy. But if I asked you about this, and I said, hey, what is the, let me make it positive. If I said, what is the y-intercept of this function, you might be tempted to say 2, because, again, it's the last number. But it's very, very important to recognize that since these are two different forms, this and this are two different forms, there's going to be a different method for finding each of these things. Just how, like, there was a different method for finding the vertex, there's a different method for finding the roots, and there's going to be a different method for finding the y-intercept. Right? Now, one way we could do it is we could simply turn this into standard form. Let's actually go through that, because you need to know how to do that anyway. Get rid of all this stuff. So one method would be, if it's so simple from standard form, why don't we just turn this into standard form? So let's do that. How would we do that? Well, what you would do is simply get rid of the parentheses. That's the definition of standard form, is simplified. So if I had x plus 3 times x plus 3, and then plus 2, so that's what that actually is, right? And now I would use FOIL, or distribution, however you want to think about it, to multiply all this out. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, 3 times 3 is 9, and we still have a 2. And now I can simplify all this, and so we can combine these together, and we can combine these together now. So that's x squared plus 6x plus 11. Now, if I asked for standard form, I said, here's something in vertex form, how would you turn it into standard form? Well, this is how you would do it. You would just multiply out everything and then combine all the like terms. And if you'll notice that once you've done this, the y-intercept is visible. So if I ask you what the y-intercept is, well, now it's visible. Now you can look at the last term, but you could not before, because this wasn't in simplest terms, right? It wasn't simplified. All right. Let's do another one. So you might be asked to convert the function y equals let's do a more interesting one. Y equals x plus 2 squared minus 1 to standard form. So if I wanted to convert this to standard form, how would I do that? Well, just like last time, I'm going to write this out as 2 parentheses. And then I'm going to leave this negative out here. I'm not going to do anything with it yet. I'm going to FOIL all this out. But I'm going to keep it in parentheses because these things here are being multiplied by a negative. I don't want to mess that up. So this is x squared plus, I'm going to do some shortcuts here because I'm assuming hopefully you're good at FOIL by now. So when you do all that stuff and simplify it, it becomes this. Now this negative is now going to change all these signs. So now I have negative x squared minus 4x minus 4 and then minus 1. So now combining those last terms, I have, forgot an x, minus 5. So this is standard form. It's kind of a step backwards if you're trying to find the vertex. So the vertex up here is visible, right? It's -2, -1. You can instantly find it just by looking at it. Down here, it's kind of a step backwards, isn't it? So turning it into standard form has its uses, but finding the vertex isn't one of them. It's definitely, like I said, not a step in the right direction. But what it does help you do is find the y-intercept, which is right here. So the y-intercept is -5. Now that's one way to find the y-intercept. There's another faster way. Two ways to think about it, in fact. If you notice, well, let me use a different example before, because that one's a little less intuitive. Let's say I give you this, x plus 5 squared plus 3. And I ask you to find the y-intercept. Well, you know that the 3 is not the y-intercept, right? We recognize that the last term in vertex form is not the y-intercept, because this is not standard form. But we do know that if we were to turn it into standard form, then the last term would be, in fact, the y-intercept, right? So if you think about what would happen if you were to multiply all this stuff out, as long as there's not a number out front, then this trick will work. I'm just going to show it to you really quick. If you think about multiplying all this stuff out, the only thing that contributes to the y-intercept really is just the number at the end. So really, even though there's all kind of stuff happening in the multiplication, 5 times 5 gives you 25, plus 3 is going to give you 28. So the y-intercept is just 28. So as long as there's no number out here, you see that? Nothing to complicate the situation. If it's just a 1, then you can use this trick. You can just multiply, and then you get 28. All right? Now, there's a better way of thinking about this, more closely tied to what the y-intercept actually is, if you'd rather think of it this way. This is probably a more mathematically consistent, mature, elegant way of thinking about this shortcut. I'll give you another example. How about this? Now think about what a y-intercept actually is. A y-intercept is the number that is on the y-axis, right? So if you think about where the function crosses the y-axis, ask yourself, what x value is this? It's going to be, well, it's always going to be 0, isn't it? And then some y. We don't know what the y is. That's what we're looking for. But you know for a fact that it's going to be 0 the x value is going to be 0 because that's what's on the x-axis. So the most direct way to find the y-intercept of basically any function, really, is to plug in 0. So if I plug in 0, 0 plus 4 squared, 4 squared is 16, minus 3 is 13. So it gives us the same result as that quick little trick I showed you a minute ago. But this is more, I don't know, mathematically motivated, if you will. And also it's going to work even when there's a number out front. All right, let's try another one. So to that point, let's try something like this. Find the y-intercept of this function. And in general, again, to find the y-intercept of any function, just plug in x equals 0. That's probably worth writing down. To find the y-intercept of any function, simply plug in x equals 0. That'll work for anything. So let's do that. So I have 2 times 0 minus 3 squared. Let me write a little better, sorry. Plus 5. Okay, that's going to be negative 3 squared, which is 9, times 2 is 18, plus 5. That's going to give me 23. So we know that the y-intercept of this function is 23. All right, so I think that's going to do it for this video. That pretty much covers everything you can do with vertex form. It's actually very easy to work with form. It's the vertex is visible. The y-intercept is easy to get to. It's not quite as easy as just grabbing the last number like it was with standard, but it's not hard. You just stick the 0 in there. And also solving for roots isn't too difficult. Set it equal to 0, get x by itself, and you're done. All right? Now, in the next video, it's going to be a very, very important one, because what we're going to do is we're going to take all the things we've learned about quadratics. That's standard form and vertex form both. We're going to talk about how to recognize when you should do what thing and kind of bring all of this quadratic stuff together into one big video to give you a better idea of the scope of everything. And so yeah, it's going to be a really, really good one. So I hope you guys check that one out as well. Thanks again for sticking with me to the end, as always, and I'll see you guys in the next one.